Friends, welcome to this class. So in last class we concluded that this Reserpic acid will have this structure, right? Beta carbolene and also vibrine synthesis. We concluded that it may have this compound, right? And they saw that we know the Reserpic acid formula, that is C22H28N2O5, right? So one oxygen OCH3 they told, and also they told that one of the alcohol and COH both are present on the ring, right? So they concluded for 4 oxygen, and they didn't conclude for one more OCH3 group, right? So that they concluded later, as we will do now, right? So these were the conclusions they draw, right? And if you see the formula of this, it is around like C12H12, right? But they want this C22, so they should give 10 more carbon. So 10 more carbon means, you may think, if this is naphthalene, it has got 10 carbons, right? Right, 10 carbons. So if you see the formula, it will be C10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 1, 2, 3, 4. C10H8. But we need more number of hydrogens, H28, right? So if we count, it is C20. So from that we can conclude that it will be like this. Not aromatic, it will be non-aromatic. If you now count, it will be C10, 2, 4, 6, 8, 10, 12, 14, 16, 17, 18. Right. So now it will be around this much, right? Like that it will be having. So they concluded that there will be 2 rings, right? So you may ask, sir, why only you took ring? Why didn't you take that open chain? For example, see, this is what CH3, CH2, CH3. Formula, if you see, it is C3H3368H8. If I take a ring like this, it will be C3246H2, H6, right? So whenever there is formation of ring, the number of hydrogens will be less. So this kind of, there will be a formula like hydrogen deficiency index, because there are 2 deficient of hydrogen, and the formula will be like 2C plus 2 plus N minus X whole divided by 2. Where C is number of carbon, N is number of nitrogen, minus H means number of hydrogens, minus X means number of halogens. Whole divided by 2, we will get how many hydrogens are deficient. From that we can see that whether it has got unsaturation, whether it has got ring, whether it is saturated, everything we can tell. This we will again study it in NMR spectroscopy, proton NMR, right? Proton NMR, there also will study about this hydrogen deficient index, right? From that we can tell that whether it is ring or saturated chain or unsaturated chain, right? From that all those things they concluded that it is ring, and it will be like this fused ring, it will be there, right? So so these conclusions they came up with because of this formula. Formula was having less number of carbon and less number of hydrogens, so they added hydrogens in the ring, that too non-aromatic, right, non-aromatic, because of which they concluded that the structure might be like this. So this will be the structure like this, right? So if this is the structure, then they can tell the number of carbon and hydrogen, they can easily tell, right? So from all those reactions, some analysis, they came up to this structure. So this Reserpic acid will have this structure. So one of the OCH3 they mentioned, and they told it will be like OH and COH both are on same ring, and both have same stereochemistry, right? So they told like this. So both OH and this acid group COOH both are on same ring, and both are above the plane, right? Because if we heat it, they can form a electron like this. This oxygen carbon bond formation happens, and there will be loss of water like this. So this is nothing but our electron, right? So this is how. So both have same stereochemistry, and both are present on same ring. So they told that this alcohol and acid, right? So they gave the position of alcohol and acid, both are 1-1 equivalent, both are present on same ring and same stereochemistry. So they concluded. So they gave 1, 2, 3 and 4. 4 oxygen, one more oxygen, what they told, it will be like here OCH3. Right, so they gave the structure like this, and they concluded for 2 molecule of OCH3, 1 and 2, and other acid, and 1 equivalent of acid, 1 equivalent of alcohol. Right, so they told structure will be like this only, and here there will be one pi bond. Right, so they gave the structure to be like this. Right, so now let us write the clear structure of reserpine now, reserpic acid. From that we will write the structure of reserpine. Right, so now let me write the structure of reserpic acid. So you just write along with me so that it will be clear. So from all those conclusions which we discussed from last 2 classes, from that they gave the structure of this reserpic acid. So nicely you draw. Right, so this is the structure. Again the ring is cyclic ring like this. Here one more cyclic ring. Right, and here both COOH, this alcohol OH, and this OCH3, all are above the plane only. Right, and this ring adjacent hydrogens were below the plane. Right, below the plane, and this ring is there, right, that hydrogen is above the plane. Right, and this nitrogen is secondary, and this is the aromatic ring, and here I have OCH3, and this is the structure of this reserpic acid. Reserpic acid, which has 2 molecule of OCH3 and 1 equivalent of acid and 1 equivalent of alcohol. Totally it gave for 5 oxygen. It accounted for 5 oxygen. Right, and they gave the stereochemistry like this. Right, so and also they numbered. Right, so this OCH3 is not above, this OCH3 is below. This OCH3 was below. Right, these things were above. Right, and this was below. Right, so this is the structure of reserpic acid, and they numbered it to be like this. See, nitrogen they numbered 1, adjacent carbon 2, and this carbon 3, and this carbon it is 4. Just a minute, no, this nitrogen they 4, 5, 6, 7, 8, 9, 10, right, 11, 12, and this is 13. Right, after 13 this carbon is there, right, this carbon it was 14, this carbon is 15, this carbon is 16, this is 17, this is 18, this is 19, and this carbon is 20, this one 20, and this carbon is 21. Right, yeah, this is how they numbered it. Right, once they numbered like this, then they gave the stereochemistry or stereochemical description for this reserpine. Right, so before giving the stereochemistry description, we know that reserpine, when we do acidic hydrolysis, we got this reserpic acid along with 1 molecule of methanol and 1 molecule of this kind of acid, COOH. Right, COOH was here, para position OCH3, adjacent OCH3, and here both are adjacent. So if I combine these all reserpic acid, methanol, and this acid, I will get structure of reserpine. So this is structure of reserpic acid. I hope you understood it. Let me combine these things. So for this alcohol, I will remove this H, I will add this acid. So it will be like CO, which is attached to a benzene ring, para position OCH3, and adjacent OCH3 and OCH3. Right, and here I will remove this acid COH. I will just make it as CO, and methanol OMe I will add OCH3. Right, so this is the thing. Right, and also one more thing you remember, this reserpine is there, right? Here OCH3 is not there, here it is simply OH. Right, because see, in a reserpine 5 equivalent of OCH3 should be there, right? So 5 equivalent means 1 equivalent, 2 equivalent, 3 equivalent, 3 equivalent and 4 equivalent, right? Yes, it's true. 4 equivalent. Let me check the exact structure, and it is OCH3. Sorry, OCH3. And this is 5 equivalent. We should not consider this OCH3. This is ester, and I told it will have 2 equivalent of ester. So one ester, TSTR, ester, and this is second ester, COO. This is second ester. So now this is the structure of Reserpine, not Reserpic acid, right? So now this is the structure of Reserpine, right? So here it should have 5 equivalent of OCH3, 1, 2, 3, 4, 5. So we told for 5 equivalent of OCH3, right, and 2 equivalent of ester. So 1 and 2 equivalent of ester. So this is the structure, and the numbering also have given it, right? So let me rub all those nonsense, right? So this is the reaction, right? So nicely we got this structure of this Reserpine. After all those chemical degradation method, we got the structure of Reserpine. So let us see the stereochemistry, right? So stereochemistry, if you see, the ring is numbered like this. So how many rings? 1, 2, 3, 4, 5. 5 rings are there. It is numbered simply like this: A, B, C, D and E, right? So for stereochemistry of these two hydrogens, as it is below, right? Ring C and D, here this hydrogen is above. So ring C and D, the both ring are cis fused, right? And the ring D and E, are transfused, right? So these are the stereochemistry, and these things C2, no, not C2, sorry, C3, and these are not aromatic, C3, and this C15, and this C16, this C17, C18, not 90, C20, 21 is not. So these 1, 2, 3, 4, 5, 6, these 6 carbons are optically active carbon, or I can call it as chiral carbon, because these are optically active. So these 6 carbons which I have numbered, C3, 15, 16, 17, 18, 20, these are optically active carbon or the chiral carbon. So this whole molecule as a Reserpine, it will show some optical activity in CHCl3 chloroform, which I had written on the first class, right? So it is optically active molecule, right? So these were the conclusions we came up with, right? So I hope you knew all those things, right? So this is the structure of Reserpine. So let us see few more reactions which we discussed in the previous classes, right? So if I do hydrolysis experiments, so what happens? If I do hydrolysis experiment, this bond will be broken, and here this bond will be broken, and here I will get alcohol, here I will get acid, that is Reserpic acid I will get, which contain within the same ring there will be acid group and there will be alcohol, and here we will get methanol, this one OCH3 will get methanol, and this thing will get acid, and the name also I had told it, right? So we will get benzoic acid, OCH3 and OCH3, and the name was 1, 2, 3, 4, 5 trimethoxy benzoic acid we will get along with methanol and Reserpic acid, and Reserpic acid will be having COH group and OH group on same carbon on the same ring. So it has got 2 equivalent of ester, like that we concluded, right? So if I do any reducing like LiAlH4 experiment, if I add reducing agent, I may not get this thing, but I will get what? Here instead of getting CH2OH, I will get CH2OH. Instead of getting acid, I will get reduced product, primary alcohol, I will get methanol, no doubt, and here instead of getting COH, I will get CH2OH. So this is CH2OH, right? So if you write for this structure, you can write, because I gave the structure of Reserpic acid also. Now this is the structure of Reserpine, right? So I hope we understood all the structure, right? So if you see partial stereochemistry of this Reserpine, right? So this is the structure of Reserpine. Reserpic acid means just here COH you add, just here you add OH, and remove these both things. You will get the structure of Reserpic acid. So partial conformation of this Reserpine, I will write it. Let me write. So it is like, see, right? So this is the thing, OCS3, and here I have NH, and I have this ring like this, and these two rings will be there, right? So they will be like this, see. Right. So one ring, I told these two are cis fused and these two are transfused, right? So this one you can see here, right? So one hydrogen is below here like this, this hydrogen is above, alright, and this is, here I have above OCH3, and here above I have COOMe, and here above I will be having alcohol OCH3, sorry, OCO, that ring we will be having. So this is the partial structure that you can Google it, in Google also you will get it, right? So this is the partial structure. And also I told for determining the nature of nitrogen, what we add methyl iodide, CH3I. When I added methyl iodide, we will get this NH is there, right? So we will get NCH3. So this nitrogen, so we concluded that NH nitrogen will be there, so it will be secondary. When I do this AC2O, or first step I will do AC2O, then what I will get? I will get NCO CH3, CH3CON, this N, this bond formation happened in first step. Second step I will add CH3I. This methyl iodide, instead of reacting with this nitrogen, it will react to this nitrogen, because this nitrogen is sterically hindered here. Since because of this steric hindrance, this nitrogen we will add CH3. So there are two nitrogens, in which one nitrogen will be having NH, right? So it will be secondary, and this nitrogen will be tertiary. This tertiary nitrogen will react with CH3I to form quaternary, because nitrogen gave to lone pair, it gets positive charge. So this is quaternary salt, right? And this was tertiary. But we concluded that both nitrogen was secondary from this reaction, acetic acid Ac2 acetic anhydride, it became tertiary, and methyl iodide it became quaternary. But that was not the thing. Both the nitrogen reacted. First nitrogen reacted this. Further, because of steric resonance, it couldn't react. Only this nitrogen reacted to form quaternary ammonium salt, right? So these were the few reactions which we discussed, right? So all those things we have studied. So I hope you understood the structure of Reserpine, Reserpic acid, and everything. So in next class, let us see how we synthesize this Reserpine in lab. Till then, take care and have a great day.